Welcome back. Now that we have our drone in our new project, it's time to start coding some functionality for our drone. Now, our drone itself is going to need a blueprint. We can't just bring in our SM drone. Well, we could, but it's not really going to do anything. It's just a static mesh actor while it's in the world here. We can press play though, and we can fly around, but the drone is just going to sit there, right? We want our drones to be active. In fact, we want it to be hostile. I'd like it to turn to face us and chase after us. I think that would be nice and ominous. Then our game will have an adversary. So I don't want my drone static mesh in the world. I want an actor, and for that, we're going to need to create an actor blueprint. So in the content folder, along with assets and maps, I'm going to make a new folder called blueprints, and all of my blueprints will be in my blueprints folder. Looks like I forgot an S there. So in blueprints, I'm going to make yet a new folder, and in this folder, we're going to have our drone actor. So I'm going to call this folder drone. And in the drone folder, we're going to make a new blueprint class. So right click, choose blueprint class. And yet again, we're going to choose actor. Don't worry, we're going to get into the other classes. Right now, we're still at actor. And as we've seen, we can do quite a lot with just actors, right? So until we've learned enough to start using the other classes, we're going to stick with actor for now. So choose actor, and we're going to rename this to BP_drone. Or if you want, you can call it bot. I kind of like BP bot because it kind of fits the name of the project and the theme. So I have my BP bot. I'm going to double click it to open it. And since we set our asset editor open location to main window, it just pops up docked right here. And I also don't need my SM drone, my M drone, or my M drone glass. So I'm going to close those. And here in BP bot, I need to set up my drone. I need to give it a static mesh. So I'm going to select my default scene route, click on plus, and search for static mesh, and choose static mesh. And I'm going to call this bot mesh. So we have a mesh for our bot. Now I can set its static mesh by clicking on the drop down, and our project only has one option. So it's SM drone. We're going to select that, and notice that our drone is already facing the correct direction. We don't have to rotate it. How nice. So we really don't even need to attach it to our default scene route because we don't need a rotational offset from the root component. Our bot mesh itself can be the root component. And we know how to make our static mesh the root component, don't we? I'd like you to think about this and do it before I do it, just to see if you remembered. That's right, we can click on it and drag it onto default scene root, and now it becomes the root component. And we can prove to ourselves that it's oriented correctly by dragging one of these into the world, and we can see that its own forward direction is pointing forward. We have to go up to the icon up here and cycle into local space to see that. And now we can go ahead and rotate and see that its own x-axis is pointing forward. It's correct, so that looks great. I'll go ahead and put this back to world space, and I'm going to zero out my drone's rotation and location with the curved arrows. Now it's right here at the origin. I'd like my drone to start at the origin, but I can move my drone forward and up a bit so that every time we press play and start at our player start location, we can see the drone right there. And it's facing the other way. Now, my goal is for the drone to turn and face me, the player. And remember, if we hold Shift and hit F1 to get our mouse cursor and we detach with the detach button, now we can turn around and see that we're actually piloting this default pawn, right? We can click on it and we can see that it's a default pawn, and the default pawn is what I would like our drone to turn and face. Now we know how to set the rotation and add rotational offsets to an actor, but how do we know where to turn our drone? How does the drone know which direction to face? Well, the drone needs some kind of reference to that default pawn. And before the game starts, there is no default pawn in the level. It gets spawned in somehow. So we have to wait until the game has started in order to get that reference to the default pawn. Well, let's go back into BP bot and open its event graph, and we're going to go to begin play. Because our bot is already in the world when the game starts, begin play is going to start at the beginning of the game, And this is the appropriate time to try to get a reference to some other object in the world. And we know that once we've started, the default pawn is going to exist and we need access to it. Well, one way to access a reference to the default pawn is to right-click in the event graph and search for a node called Get All Actors of Class. We're going to select that, and this function is going to give us all the actors of a specific class. Now, we know that everything in the world is an actor. So if we were to specify an actor class with this dropdown, and if we were to choose actor, we would get all the actors in the level, and they would come out of this function through this output pin called out actors. And we see that it's an array of actor object references. An array is a collection of values. It's not just one value, it's multiple values. It could be 1, it could be 100. So for one, we have to know how to treat arrays and how to get data out of them. And two, we need to specify a class that's specific enough that we don't get too many actors. Now, I'm going to reveal something that you may not have understood previously. When we press play and get that default pawn, the default pawn is something that exists in the level, right? It's an object in the level. And we've already learned previously that all objects in the level are actors. In order to be placed in a level, or spawned in, as our default pawn is, it has to at least be an actor. Anything more basic than an actor is not capable of being placed in a level or spawned in. So that tells us that our default pawn is an actor. But we also know that its class is pawn. Well, this brings us to an important concept called inheritance. You see, the pawn is an actor, but it's a more specialized version of the actor class. It has more capabilities. For instance, it has the ability to be possessed. When we control the pawn, we're possessing the pawn. We have possessed it and now we're moving it around. That's an additional behavior that actors don't have. So a pawn is an actor with extra capabilities. It inherits all the qualities of the actor class, but also has additional capabilities that are unique to the pawn. We say that the actor class is a parent class to the pawn class. And we'll talk more about this inheritance thing. For now, that's all you need to understand, that a pawn is an actor. But an actor is not a pawn. It's not a two-way relationship. So in actor class, we can specify pawn as the actor class. And we know that there's only going to be one pawn, the default pawn, in our level. So if we call get all actors of class from begin play, we'll get an array, and that array will contain all actors of the specified class that exist in our level. And we specified the pawn class, so we only expect to see one item in this array. And we can always loop through an array and do something for all the items in the array. To do that, we drag off of out actors and type for each. And we get a for each loop. What this does is it takes every single item in the array and executes loop body for that item. And each item has its own index, which is just an integer starting at 0 for the first item or element and incrementing for each element. And the array element is the actual item in the array. So in this loop body, if we wanted to, we could print a string, and we can print out the index and the name of the array element. We see that it's a pawn object reference, and because pawns are actors, it inherits all the functions and variables that actors have, which means we can get the get object name function, which will give us the name of the object. So I'd like to append a string and show the index and the name of each element in this array. So I'm going to get an append string node, just the append node for strings. And A is going to be the name of the object. B is going to be comma space index colon space. And then we'll add a pin and we'll convert the array index to a string for C, and we'll hook this up to print string. And print string is only going to last 2 seconds unless we change its duration. I'm going to change it to 20 seconds. So now we can go ahead and play test, And we'll see that we get default pawn index 0. That's the only element in this array. So get all actors of class only got us an array with one element because we specified the pawn class. But if we were to specify just actor, then we'll get all the actors in the world. And this can be an expensive operation if there's a lot of actors in the world. Now, if we compile, we get errors now because we've changed our actor class to actor. Well, we can get a new get all actors of class node and choose actor and drag out of out actors and get a for each loop. And we can replace our old for each loop. I'm going to hold control and move my execution pin down to my new for each loop. And I'll do the same thing for the blue line to array element and the green line to array index. And I'm going to redirect my begin play execution wire down here as well. And if I remove these old nodes, I can now compile successfully. So changing our actor class has changed the types that we're using here. So we just needed new nodes. Let's go ahead and press play. And now we see all the actors of the actor class that exist in our world. And there's a good number of them. So if we're not specific enough, that array is going to contain a lot of different actors. So get all actors of class is not always the best choice. Just because looping over every object in an array like this can be expensive if the array has a lot of items in it. But we know in this specific game, we're only going to have one pawn. So we know that our array will only have a single element to access. So we're going to change this back to pawn and click compile. Notice we don't get an error when we go from actor to pawn. And that's because a for each loop that takes in actors can take in a pawn because a pawn is an actor. Now we know that this is only going to be an array of one item, right? So we don't really need to loop over the entire array. What we could do is drag out of out actors and type get, and we'll get a copy of that reference to one of the actors in the array. And the very first actor in any array has index 0. So array indices start at 0, and if we get the first element, that's going to be the first item, which in our case is the only item. So we don't need for each, we just need get. And we're going to get that first item. And just in case this array doesn't have a valid item at index 0, we can check to see if 0 is a valid index for this array. We do that by dragging out of out actors and typing is valid index, specifying the index we want to check. We can check index 0. And we can hold B and click to get a branch because is valid index returns a Boolean. And it's going to be true if 0 is a valid index. That means that there is an item at element 0. And our get node is going to return that. So we can plug that into get object name. We can still print the index 0 if we want to. And we can hook this up to print string. And if we go and play test, we'll see that we get the default pawn at index 0. So now that we know how to get the default pawn, our goal is for the bot to rotate towards the pawn, to face the pawn. So instead of printing a string, I just want to store a reference to that default pawn. That's going to be the target for our bot. So we know how to promote a value to a variable. We can either drag off and select promote to variable, but another shortcut is to right-click on the output pin and choose promote to variable from here. And this new variable is going to be called target pawn. It's the target for our bot, and we're going to hook that up to true. We only want to set this variable's value if 0 is a valid index in this array. That way we know we have a valid pawn. And now that we have a pawn, we would like to set our rotation to face that pawn. We would like our drone to always be facing this target pawn. And we can do that in the tick function. So let's go down to event tick, and all I'm going to do for now is set my actor rotation. If we right click, we can type set actor rotation, and every frame we're going to set the rotation to a rotator that will make our drone face the pawn. So how do we get that rotation? Well, there's a handy node to get a rotation specifically designed to look at one direction from another. Let's right-click and type find look at and get find look at rotation. This node takes in 2 vectors and returns a rotator. We simply need a start location and a target, and the rotator returned is going to be exactly the rotation we need to look at the target from the start location. So what I'd like you to do is finish this out. This is a small challenge, but go ahead and finish up the nodes to this so that our drone is facing the target. So every frame we're calling set actor rotation and setting that rotation so that the drone is always facing our target pawn, no matter where the target pawn is. Pause the video and give this a try. Okay, so we want the look at rotation from our drone's position to the position of our target pawn. So the start location can be the location of our drone. We're going to use get actor location for that and hook that into start. And we also want our target pawn location. So we're going to drag out and get target pawn and get actor location from the target pawn. And we're going to hook that in for target. And we simply need to hook our return value into new rotation. And we need to hook this up to event tick. So every single frame, we're setting our actor's rotation. Let's see how this looks by pressing play. And look at that. Our drone not only faces us, but if we move around, the drone continues to look at us, which is actually really creepy. But that was our goal. We wanted our drone to face us. So that's step 1. We know how to make our drone face us, but I'd like it to do so in a more smooth manner. For instance, if we start off behind the drone, I'd like the drone to very smoothly turn and find us, rather than just snap to face us right away. And that's going to involve a concept called interpolation. And we'll learn about that next. Excellent job, and I'll see you in the next video.